Hi guys, in this video I'm going to talk about Llama Stack and how we can achieve enterprise AI applications that can be scalable. So we have different AI components and we want to see if we can have a similar concept to Kubernetes that we can actually connect different components as a plugin. So without further ado, let's jump right into it. Welcome everyone to the channel, AI Fun Fact for All. For those of you who are in this channel, my name is Pedro. I have a PhD in computer science, and this channel we talk about AI and machine learning and how we can use it in order to improve our efficiency. As we mentioned, we want to talk about Llama Stack. Let's say you have your AI components in here and you want to basically connect the different stuff that you have. So in the very obvious application, it would be your LLM inference that you basically talk to it, and then maybe you want to connect it to your databases to retrieve information. So we have the RAG component. Maybe you want to basically connect it to the different APIs or MCP servers. That's where we have the agent component, and maybe you also want to evaluate it on the fly. So you want to have your basically eval components, and if you want to set up some guardrails or something to make sure that the stuff that you have is only available to yourself and you don't basically you're complying with the security, you might want to consider this. But in order to make sure that everything follows a specific streamline, we want to basically use a process that make everything for us possible, and that's where we have the Llama Stack. So basically what we want to do, we want to standardize this process in order to make sure that we follow a specific guideline and make sure that we can actually run it from a developer's laptop into enterprise scale solution. Same as how we can do it in Kubernetes, that it will do lots of process such as, for example, CI/CD and development and DevOps and so on to basically automate this process. So similar how to Kubernetes actually create this streamlined process and make it available for us to basically talk to different vendors, have different projects, streamline some workflow for us. Now we want to basically have a workflow that make us access a different component completely easily and without thinking too much about onboarding different components into it. So basically, let's say in my application I want to connect to a specific LLM provider. In my for example developer, I'm gonna use, for example, Ollama as my inference, but then after that I'm done and I want to productionize it, I'm gonna use, for example, VLLM. So what the process is that we want to make sure that we don't have to be worried about this low-level process and changing different components. We want this to be completely standardized, and the same goes actually for the others, like for example agents. Maybe I'm gonna talk to different APIs directly, or I'm gonna talk through a standard MCP. And the whole concept of MCP, as we talked in the previous video, is to basically talk to the different APIs on the backend and then facilitate this process, so I don't need to each time define how I'm gonna pass the different components to that specific API. That will be handled by the specific API itself. I just want to have this medium as a way for LLM to basically easily talk in a conversational format with the available AI applications. Now let's see how it is done in the Llama Stack architecture. So we're gonna have some Llama Stack APIs. That's where we define our API, and then we have some providers. So what was important in here is that we don't want our architecture or code to be dependent on provider. So what are the different Llama Stack API that we have? A few important ones are the basically the inference API, and then for example we have something about the vector IO to handle the process of the different vector databases. On the provider side, we basically have the different version of them. So for example, a provider can be Ollama. That's basically one way that we can actually provide an inference to the LLM. It can be VLLM, as we talk about it, other different providers, for example, third-party providers. And for example, for vector database, it can be ChromaDB. But what will happen is that the Llama Stack API doesn't actually know how to do the different downstream tasks, but rather know which a specific API to call and what context to give them. So this will basically try to abstract away the fact that you need to be dependent on the specific provider's unification or whatever specification do they have. And then on top of this, distros or the different distribution. So what distros actually does is basically you can think of it as a packaging on top of what we already have. So let's say you have a complete separate package for your local setup that you have, for example, Ollama, and then you have ChromaDB and so on, and then you want to have something for your edge, you want to have some specific result for your production environment or for example for your inference and so on, or you can have some for your cloud. And this set of packages can actually be set up as easy as setting up a config file. Now let's consider a very simple but frequent scenario. Let's say we receive some events, and then we want to go and access our databases, and then we want to update our CRM and maybe, for example, contact through a Slack. So what we want is that our agent, we want to have access to basically the Postgres database, and also we wanted to be able to be connected to basically the Slack. So how we do it is that these providers will actually be available through the Postgres and Slack, and our agent code, based on the philosophy of the Llama Stack, doesn't need to know or doesn't have to be dependent on the tool that we are using. So basically it is completely decoupled from the tool that we are using. So the agent code is completely abstract, and it doesn't matter what basically tooling we are using. Later on, if I change the Slack, for example, to some other platform, if I choose the Postgres to another, I don't need to change the logic of my agent. So that's kind of a modular dependency and plugin core functionalities that it is a convention of the Kubernetes, and this is going to be applied to the AI applications through the Llama Stack. And there you have it, guys. We went over Llama Stack architecture and how is it similar to Kubernetes for the AI applications. We discussed that when we are using this Llama Stack for enterprise-ready AI applications, we don't need to worry about what are the downstream tools that we want to use, or what are the specific databases that we need to have, and we need to shift the focus from those low levels into some higher level development and deployment, so make us move faster while adhering to the standardized process for enterprise ready AI applications. If you enjoyed the video, make sure to like it. More importantly, subscribe to the channel so you get more videos like this. I also suggest you to watch this video that I talk about Llama Stack, first time that it was basically introduced, to go over some practical example and some code that you can take a look. Or if you are new to AI and want to know the most important things that you must know about the concepts of AI, make sure to watch this short video so you get a better understanding. Thanks for watching and see you until the next one.